Regulators! Regulators! Mount up!
Well, good morning, good afternoon, or good evening, depending on what time of day it is that you're watching this video. On this lesson here, we're going to go over the law of sines. Okay, so we're going to be talking about the law of sines. First, I want to take a moment and just read this quote here. I'd rather attempt to do something great and fail than attempt to do nothing and succeed. Because that's powerful, right? If you want to do nothing, you'll be successful at doing nothing just by doing nothing. If you want to be somebody, you want to do something, you've got to attempt to do it. Even if you don't reach your goal, you're still better off than you were before. Okay, so I really like this. Thank you, Robert H. Schuller, for this quote. All right, now let's talk about the law of sines. Okay, the law of sines is going to open up, oops, get off there, a whole new avenue for us here to solve things dealing with triangles. Okay, the law of sines talks about any triangle. Okay, in any triangle, if we label the angles with capital letters, like A, B, C, then the sides opposite are lowercase letters. So opposite angle A, capital A is side A. Opposite capital angle B is side little b. Opposite capital angle C is side little c. The law of sines tells us that the ratio of the side to the sine of the angle opposite is equal for every side angle pair. That's really useful, right? Side A divided by the sine of A equals the measure of side B divided by the sine of B, which equals the measure of side C over the sine of angle C, as those ratios are always true. So now if they give us a triangle and they tell us 3 out of the 6 things, there's 3 angles, there's 3 sides, if they tell us 3 of those, we should be able to find the other 3 if we have a side angle pair. So let's give this a shot. Let's try this right here. So we've got triangle ABC. Side A is 5.46, angle A is 42 degrees, and angle C is 56 degrees. We want to find the missing parts of that triangle. So we know angle A and angle C, so we need to find angle B. We know side A, we don't know side B, and we don't know side C. So those are the 3 things we got to find. And now, what I do whenever I do these problems, I just sketch a generic triangle that looks like an equilateral triangle. I know it's not really equilateral, but I'm going to go ahead and sketch a generic one like that, and then I'm going to label what I know. Let's maybe call this angle A, this angle B, and this angle C. All right, angle A, I'm told, is 42 degrees. Angle C is 56. And then they tell me side A is 5.46. Okay, now, it's going to be real easy to find angle B, right? All 3 angles have to add to 180. So if this is 42 and this is 56, I add together, let's see, 42 and 56 is 98. So 180 minus 98 gives me that this is 82 degrees. So angle B is 82 degrees. All right, I'll go ahead and grab my calculator just to verify that. I don't want to make any careless mistakes here. But because when I'm waiting for the calculator to pop up here, if we think about some things we know about triangles now, when I solve this, oops, come on. Well, here we go. I got the calculator here now. All right, here's what I did. I did 180. And I subtracted 42. Whoops, get the minus in there. I subtracted 42, and I subtracted 56. Okay, that's how I got 82 for this angle. Okay, now, when I look at things, I know in a triangle, the largest side is opposite the largest angle. So since angle B is the largest angle, I know already side B's got to be my biggest side. A is the smallest angle, so side A has to be the smallest side, and then C is going to be the middle side. Okay, now that I know the law of sines, since I know side A and I know angle A, I'm going to put the length of side A, 5.46, over the sine of 42 degrees. So I'm doing the law of sines. A side divided by the angle opposite. Now that should equal, I'm going to go ahead and find the biggest side first. B's got to be the biggest side, so that should be B over the sine of angle B. All right, so then to solve this, I'd cross multiply and divide, and angle B, or side B, is going to be 5.46 times the sine of 82 divided by the sine of 42. Okay, now you guys look at this. This is going to happen to you sometimes. I'm getting a crazy answer. There's no way the side could be negative 1.86599 units, right? That tells me I should have checked ahead of time what my angle is in, what mode. I'm in radian. These are degrees, so I got to be in degree mode. So I'm going to change it to degree mode, and I'm going to do that exact same thing again. Now look what I get, 8.08. So side B is 8.08 units. 8.08. Okay, now I'm going to go through and do the same type of thing and find side C. Right, so I'm going to put 5.46 over the sine of angle A, which was 42 degrees, and that should equal side C over the sine of angle C. Whoops. I know angle C is 56 degrees. So in my calculator, I'm going to type in the exact same thing. Right? I'm going to cross multiply and divide, but this time it's going to be the sine of 56 times 5.46. I'm going to do 5.46 times the sine, this time sine of 56, sine of angle C, and I'm going to divide it by the sine of 42. And there's side C, 6.76. I like to go 3 decimal places, but 6.76, and the problem, they only gave us the stuff to 2 decimal places, so maybe I'll just go 2 on this one, 6.76. 6.76 units. Okay. Now, guys, like I said, the ratio of every side divided by the sine of the angle opposite should be the same. So watch this. If I take side A, 5.46, and I divide it by the sine of angle A, 42, I get 8.1598. I'll do the same thing with side C and angle C. So side C, I just said, was 6.76. So I'll take 6.76, whoops, almost a sabotage situation, 6.76, and I'll divide it by the sine of 56. Yeah, 8.15. It's off a little bit because we rounded, right? I'll try the same thing with B. Side B was 8. We computed to be 8.08. I'll divide that by the sine of 82. That 8.15, right? A side divided by the sine of the angle opposite will always be the same. That ratio is always the true. We call that the law of sines. All right, you guys, here's one for you to try to do. My advice to you, I've already got it worked out. I've got the answer here. Pause the video, work this out, and then play it again to check your answer. Okay, so I'm going to uncover the answer right now. There are the answers you should get for this one here, right? If we're given that side X is 22.5, so I put that here. And then angle X is 41.8, so I put that angle opposite side X. And they're telling us angle Y is 10.2 degrees, so I put side Y opposite. And we had angle or side Z and angle Z. So you use the law of sines to work this out, and those are the answers you should get. All right, let's try another one here. And you guys, on this one, I got a feeling Well, actually, I know because I set it up. This is going to be an example of what's called the ambiguous case. Okay, and it's ambiguous when they give us two sides and an angle. And remember, ambiguous means not clear, so it means whenever this happens, we could get just one nice triangle, or we could get two, or there could actually be no triangles with these dimensions. We have to figure it out. So again, my advice, what I do, I just sketch a generic equilateral looking triangle. And I'm going to label the sides. So, or I'll label this. I always like to call this A, B, C. Okay. So they're not telling me angle A, they're telling me angle B is 28 degrees. Angle B is 28, side B is 16. So that goes right there. Side C is 21. So the things we don't know are angle A, angle C, and I'll write in here side A. Right? So we've got to find this angle, and this side. So now when I start this out, when I use the law of sines, I always use the side angle pair. So I'm going to put 16 over the sine of 28 degrees. Okay, now they gave me side C, so I'll find angle C first. So I'll put side C, which is 21, over the sine of angle C. Now if I cross multiply, I'm going to get 16 times the sine of C is going to equal 21 times the sine of 28 degrees. If I want to find C, I divide by 16. Okay, so guys, here's a case where if I want to find angle C, I have to take the inverse sine of 21 times the sine of 28 degrees divided by 16. Right, when we don't know the angle, we do the inverse sine. So I'm going to set this up here. I'm going to go inverse sine. Then I got to do 21. Oops, I'm going to have to put this in parentheses also, or else it will do the inverse sine of 21 first. And watch, well, no. Yeah, I'll do that. Let's say I forgot my parentheses. I do the inverse sine of 21. Let's see, what was it? 21 times the sine of 28 divided by 16. So 21 times the sine of 28. Oops, get the sine in there. Sine of 28 divided by 16. Watch what happens if I try to do this. Immediately it tells me there's an error. And the reason there's an error is you can't take the inverse sine of 21, right? Sine, the answers for sine always have to be in between -1 and 1. 21's way too big. So I got to put this in parentheses to tell the calculator to do all of this first. Do 21 times the sine of 28, then divide that answer by 16, then tell me what angle has that for its sine. Boom, there we go. So I get 38.04 degrees, right? 38.04. So let's write that down. We just found out that angle C, and maybe I'll write it right here. Angle C is 38.04 degrees. Okay, now, if I put that in here, right here, right, all three angles have to add to 180. So if I'm saying this angle's 38.04 degrees, then to find angle A, I take 180 minus 28 minus 38.04. Come on, decimal point, you let me down, 38.04. So angle A is going to be 113.96 degrees. 113.96 degrees. Okay, now, guys, obviously my sketch isn't good. Angle A is an obtuse angle. But now we've got to go back for a second and let's think about something. Whenever we do the sine, or we take the sine of an angle, right? Maybe I'll even go on a separate sheet here. Okay. Remember, we've always said that advanced students take calculus. It's a little acronym to help us remember that sine is positive in the first quadrant and the second quadrant. Or we remember sine goes with y, so whenever you go up, sine is positive. So when we did this right here, when I took the inverse sine, and I got that angle C was 38.04. It could be that we had a triangle in the first quadrant, and this angle right here is 38.04. But it could also be that we have a triangle in the second quadrant right here, and this angle is 38.04 degrees. And now we want to find this angle. So we do 180 minus 38.04. Right, if I do 180, come on, sabotage right there. 180 minus 38.04. Look what I get, 141.96. So the angle could also be 141.96 degrees. All right, watch if we check that. You guys watch this. All right, if I take the sine of 38.04, let's compare that to the sine of 141.96. See that? They're exactly the same. Sine is positive in the first and second quadrant. So that tells me when I go back to this other problem, right, there could be two triangles with these dimensions. The other triangle could have a measure for angle C of 141.96 degrees. So this angle right here could have been 141.96 degrees. Then we got to check, would that fit in this triangle with this angle? Well, yeah, 28 plus 141 is 169.96. So that means there could be two triangles with these dimensions. And then the other triangle, angle A, would be 180 minus 141.96 minus 28. So angle A could be 10.04. Oh, there's my cursor. 10.04 degrees. Okay, so that's why they call these the ambiguous case, because there could be more than one triangle. Right? We're going to get two sets of answers here. So now the missing thing we got to find is, right, we've got side C, side B, angles ABC. Now we just have to find side A. Right, so we're going to have two different side A's. The first one, if I use my angle side pair, the 16 and the sine of 28, with the B and side B. So 16 over the sine of 28 degrees. In this first triangle, that would equal side A over the sine of 113.96 degrees. Right, so when I cross multiply and divide, I'll get 16 times the sine of 113.96. I divide that by the sine of 28. And I get angle A is 31.14. Right. So angle A is 31.14, which in that triangle, angle A was the biggest biggest angle, so side A has to be the biggest angle. Now in the other triangle, if I do the same thing again, if I put 16 over the sine of 28 degrees, now to find side A, I've got to put A over the sine of angle A, which was 10.04. And in this triangle, angle A is the smallest angle, so I'm expecting side A to be the smallest side. So I do everything I just did on that last problem, except I replace the sine of 113.96 with the sine of 10.04. So I do 16 times the sine of 10.04 and divide that by the sine of 28. In this triangle, side A is 5.94. 5.94. Okay. So there's two different triangles with these dimensions in this example. Okay, and always to check for that second triangle, when we use the inverse sine to find an angle, we have to check there's two possible angles, right? In this case, we figured out that angle A could be 38.04 degrees, or it could have been 141.96 degrees. And the way we checked that was to put it in both quadrants. Okay, so there's a nice example there we've just done together. Now let's see how we could do on this one right here. Okay, so we got triangle ABC. A is 4, B is 5, and angle A is 27. So again, I would draw a generic triangle. Now, if I want to, I can try to mess around here and get this angle A to be a small acute angle, but that just takes more time than it's worth, right, to try to draw the figure to scale, right? It's better to just draw a generic triangle, and then let's label it here. Let's say I call this right here side A is 4, then this is angle A. Okay, if side B is 5, maybe I'll put it right here, then this is angle B. So this is angle C, and this is side C. Right, and I know angle A is 27 degrees, so I know this angle. Okay. Now, 27 is pretty small. 4 is smaller than 5, so I'm expecting angle B to be bigger than 27. Okay. Now, when I set this up, if I go to try to find angle B, right, I've got a side angle pair here, so I'm going to put 4 over the sine of 27 degrees. That should equal 5 over the sine of B. So like in that last problem, if I cross multiply, I'm going to get 4 times the sine of B is going to equal 5 times the sine of 27 degrees. Then I'm going to divide by 4. So then to find my angle, angle B is going to be the inverse sine, or the arc sine, of 5 times the sine of 27 degrees divided by 4. Okay. So let's see now. When I grab my calculator, I grab the calculator and go to do this, I'm going to do inverse sine. Right, and I know I need a parenthesis, and 5 times the sine of 27 divided by 4. Okay, so angle B could be 34.5. All right, let's go ahead and just go one decimal place on the angles. That should be accurate enough. 34.6 degrees. Okay, now what we did in that last problem, I know it could also be 180 minus that answer. Right? It's also a possibility that it is 145.4. So angle B could be 34.6 degrees or 145.4 degrees. Right? We've got those two possible answers. So now I'm going to go back and look at my triangle here. Okay, and let's say it's 34.6 degrees. So this is 34.6 degrees, right? If I add these two angles together, or actually, even before I do that, let's go back here. This is 34.6. Maybe this would be a better illustration for you. We're saying there's a possibility there could be two triangles. All right, so I'm going to draw this possible second triangle here, where this is angle C, this is B, this is A, this is side C. We know this is 4, we know this is 5, and this is 27 degrees. Right? We're saying we could have a possibility that angle B is 145.6. So let's say I put 145.6 degrees in here. Okay, is this triangle possible? Well, all three angles have to add to 180. So let's see. If I do 145.6, then I add the angle I was given, which is 27. That adds to 172.6, right? If I take 180 and I subtract that answer, then my angle C could be 7.4. Right, so if I come up here, this angle could be 7.4 degrees. It works in this triangle. Right. So there are two possible triangles. All right, so when I write my answers here, I'm going to have two possible solutions. Okay, so in one of the triangles, angle B could be 34.6 degrees. In the other triangle, angle B could be 145.4 degrees. Okay, now we still have to find angle C. So in this triangle, I just figured out that angle C could be 7.4 degrees. In this other triangle, C could be 180 minus, so let's see, 180 minus 34.6 minus 27. So it could be 118.4 degrees. 118.4 degrees. Okay, now the last thing to do is to find side C. So to find side C, maybe I'll squeeze in right here. In this triangle right here, all right, I'm going to take the angle side pair I was given. I'm going to put 4 over the sine of 27 degrees. That should equal side C over the sine of angle C. And in this triangle, we're saying C is 118.4 degrees. So on my calculator, I'd cross multiply and divide. So I would take 4 times the sine of 118.4. I'd divide it by the sine of 27. Right, 4 times sine of 118.4 divided by the sine of 27. And side C would be 7.75 degrees. All right, that would be in this triangle, so side C would be 7.75. Now, in the blue triangle, the only thing that we would change is we change angle C to 7.4 degrees. And then when I work that out, I just take my calculator here, I do the exact same thing, except instead of the sine of 118.4, I'd make it the sine of 7.4. And I get 1.13. So I get C is 1.13. Okay. So in this triangle here, C is 1.13. And again, we had two different triangles because there were two different values when we found our angle B. There were two different values that angle B could be. Okay. Now, you may be asking, how about that very first example, or the first two examples? Why was there only one triangle? Well, here they gave us two angles, so there's no ambiguity there. The third angle has to be 180 minus those two angles. Same thing with this. We were given two angles, so if we do 180 minus 42 minus 56, B has to be 82, right? If they only give us one angle, then we always have to check. There's the possibility of two different angles when we try to find an angle. So there could be two different triangles. All right, let's try this one. And here's another one where they only give us one angle. So we're going to have to make sure and check, hey, there could be one triangle, there could be two. Okay. Let's give this one a shot right here. Again, I always like to start out with just drawing a generic equilateral triangle, and then I'll label it. Let's see, angle B is 115, so let's say this is B. This is 115 degrees. If I wanted to, I can really draw it so it's obtuse, but I'm not gonna. This is 23.8 because it's opposite. All right, let's say this is side C, 45.6. So this would be angle C. So this is going to be angle A. This is going to be side A. All right. Okay, as soon as I look at this, I know there's a problem, because 115 is clearly going to be the biggest angle. These two angles together right here have to add to 65, because all three angles have to add to 180. So the side opposite B should be the biggest side, but 23.8 isn't bigger than 45.6. So I know there's something rotten in Denmark, right? And what I'm thinking of myself right now is there's no triangle with these dimensions. There's no triangle with these dimensions. It's not possible, because side B has to be the biggest side, right? But if I didn't spot that, let's say I'm not being careful, I'm not using common sense, right? Then I would try to use the law of sines. I'd put 23.8 over the sine of 115, and I'd let that equal, let's say 45.6 over the sine of C. And if I cross multiply and divide, I'm going to get the sine of C is going to be 45.6 times the sine of 115 degrees over 23.8. Right? So to find C on my calculator, I'm going to do the inverse sine. So I would do the inverse sine, and I'm going to put 45.6 times the sine of 115. So in parentheses, I put 45.6 times the sine of 115, and then I divide it by 23.8. And I get that error, right? There's an error because there is no such angle as that possible right there. Okay, so watch, you guys, if I take, if I multiply 45.6 by the sine of 115, 45.6 times the sine of 115, and then I divide it by 23.8, that number's bigger than 1. There is no angle that has a sine of that, right? The ratio of the side opposite a triangle to the hypotenuse always has to be in between -1 and 1. So there's no such triangle here. Okay, so it's nothing to do. There's our answer. All right. Now, you guys, the other thing they give us in this lesson is how to find the area of an oblique triangle. Okay, the area of any triangle is 1/2 the product of the lengths of the two sides times the sine of their included angle. Okay. So let's picture this. They write it out here, but let's picture this. Let's sketch again just a generic triangle here. All right, and let's call this ABC. So this is side A, this is side B, this is side C. So what they're telling us here is if we do 1/2 B times C times the sine of A, that would give us the area of the triangle. So 1/2 B times C times the sine of A. Or we could do 1/2 AB times the sine of C. So 1/2 A times B times the sine of C. Notice how they're always taking the angle in between the two sides. 1/2 AC times the sine of B. So here's A, here's C, and here's B, right? So this is saying that you take 1/2 the product of the lengths of two sides, and you multiply that by the sine of the angle in between them. You can find the area of any triangle. Right? So here's an example for us to try. Let's find the area of a triangular lot having two sides of lengths 90 meters, 52 meters, and an included angle of 102 degrees. All right, so we got some triangle goes way out like this. I'll try to draw an obtuse angle. So this is 102 degrees. Okay, that's an included angle. That means it's in between these two sides. So maybe this side is 90 meters and this side is 52 meters. Right? This formula right here tells us all I have to do to find the area of this triangle maybe I better say area so you don't think I'm saying A. The area of this triangle is going to be 1/2 times 90 times 52 times the sine of 102 degrees. So if I do this in my calculator, I like to do 0.5 for 1/2 so I don't have to use the fraction. 1/2 times 90 times 52 times the sine of 102. Area of that triangle is 2,288. 2,288.865 meters. 865 meters squared. Right? So that makes this formula makes that pretty darn easy. Right? If we wanted to, we could go through, maybe in class we'll go through and I'll show you where that formula comes from. Okay? But for practical purposes to use it, you take 1/2 times the product of two sides times the sine of the angle in between. So here's one right here. Let's do this one, and I like this example because I threw minutes in there. So it could help refresh our memory. Okay, if we've got this triangle, and I'm just going to go back to my generic triangle. Okay, angle A is 17.2 or 17 degrees 12 minutes. So that means this is side A if that's angle A. Okay, side B is 10 inches. So that means this is angle B. Side C is 13 inches. So this is angle C. Oh, look at that. I've got two angles, or two sides and the angle in between. So the area of this triangle should be 1/2 times 10 times 13 times the sine of 17 degrees 12 minutes. Okay, piece of cake. All we do now is type that in the calculator. So I do 0.5 times 10 times 13, and then I multiply that by the sine of 17. Now remember, to get to degrees, minutes, seconds on these Casios, we go option, we scroll over to angle, and there it is right there above that 4. 17 degrees, 12 minutes. So the area would be 19.221 inches. 19.221 square inches, I meant to say. Boy, you guys, that's a nice, useful formula. Right? Cuts down on work right there. Makes it very nice. All right, so we've got a lot of sines. We've got our area of an oblique triangle. Let's see if we can apply these things to a word problem. Okay, this would be exciting. I know a lot of you look forward to this. You look forward to word problems. So let's try this right here. So the course for a boat race starts at point A, and it says in figure 6.9. I covered up the figure. I want us to draw this, okay? So it starts at point A and proceeds in the direction south 52 degrees west. So here's what I think we should do. Maybe I'll do it in red right here. Let's say this right here is point A. So it starts at point A, proceeds in the direction south 52 degrees west. So I'm going to sort of do a broken dotted line. This is my compass, right? North, east, southwest. So instead of going due north, right, instead of going due south, this boat swings 52 degrees to the west. So instead of going straight down, it swings over this way, right? And it swings over 52 degrees. So in between the north-south line and where the boat went is 52 degrees. Okay, that gets it to point B. So let's call this right here. Okay, so here is point A. Let's call this right here point B. Okay, then in the direction south 40 degrees east to point C. So it's going to do the same type of thing. I'll do a little compass on here to help us out. But this time, instead of going due south, it swings to the east. So this time it's here, and it swings to the east. And here's where I needed to read the I read to myself the rest of the question. It says that south 40 degrees east to point C, and finally back to point A. It says point C lies 8 kilometers directly south of point A. So if I have point A and I go directly south, there's point C. There's point C, and it's 8 kilometers directly south. That's why I had a little pause when I started drawing this, right? This was south 40 degrees east. So instead of going due south, it swung 40 degrees to the east. I didn't know how far to go. I was thinking about how far to go, and I looked back up the problem, and I saw that it said point C is directly south of A, so I knew to stop right here on the north-south line. Okay? So now it's saying approximate the total distance of the race course. Well, let's see. It went from here to here. Well, it's jumping over. From here to here, and then to there. All right, so we want to find this distance right here. Oh, maybe I'll call this, let's say this is X. Oops. This is X. I'll do it in a different color so it stands out. I'll do it in blue. This is X, and this is Y. We want to find those two things. Okay, and you know what? While we're right here, let's check. Did we draw this correctly? Yep, went this way. This angle's 52, just like we got. Then it went back this way. This angle right here is 40, and that was 8 kilometers. Okay, so we've got it drawn correctly. So now we just got to work with it. Okay, and that's the toughest part of a word problem like this, is drawing a picture. But remember what Rod Stewart said. Every picture tells a story, don't it? Okay, so now we've got this. So let's see here. I've got this triangle. There's a couple things we can do here. If this is 52, and then from my geometry days, let's see, I know this right here should also be 52 degrees, right? Because the east-west lines are parallel. This is a transversal. Alternate interior angles have to be congruent. Right, also this angle and this angle right here are complementary. They have to add the 90, so that means this one has to be 38 degrees. Same thing here. If this is 40, this one has to be 50. Right, so this entire angle right here is 88. Okay, so I'm going to go ahead, I'm going to come in here, I'm going to erase this out and just write 88 in here. This is 88 degrees. Well, if this angle's 52 and this one's 88, together that adds to 140. That means this one has to be 40 degrees. Because look at this. We've got a triangle. We know all three angles. We know an angle side pair, 8 kilometers and 88 degrees. We can use the law of sines to find the missing things. So let's say I want to find x first. So I'm going to put 8 kilometers over the sine of 88 degrees. Now if I want to find this distance right here, this x, then I just put x over the sine of 40. Right? If I want to find y, I start out again with 8 over the sine of 88 degrees. And I put y over, y is across from 52, so y over the sine of 52 degrees. So then these are set up nice. To do this in the calculator, let's see. I want to make sure I stay on here, but I just cross multiply. So I do 8 times the sine of 40, and I divide it by the sine of 88. So 8 times the sine of 40, divided by the sine of 88. There's x. And then to find the y, I do the same thing, but I use the sine of 52. So 8 times the sine of 52 divided by the sine of 88. So y is 6.307. So if I add those together, I'm going to take that 6.307 and I'm going to add to that 5.145. 5.145. So total distance of the race is 11 point, you know what, why don't I make it easier on myself? Take a picture of this. So the total distance of the race is 11.453 kilometers. 11.453 kilometers. Guys, look at that. I mean, mark this down. Oh, wait a second. I'm going to say mark this down on your calendar. This is a big day in your lives. Learning the law of sines. You could never do something like this before today, but don't make the careless mistake that I just made. Okay, and hopefully you guys have caught it, and when I explain it here, you'll say, yep, that's what I was thinking. But you guys watch this. The boat started here and it went to there, right? And we figured it out. That was 5.145 kilometers. Then it went to here, which was 6.378 kilometers. We rounded off. So I added those together. That's not the entire race. Then it went back this way 8 kilometers. So I have to add 8 to this answer. Right? This should be 19.453 kilometers. Right? We got to finish the race. You can't just go here and stop and say, hey, I'm done. You got to go back. You had to go back to the distance, to the beginning, right? See, then they went back to A. Boom. So 19.453 kilometers. All right, I know what you're thinking. Let's at least do one more. This is so much fun. So here we go. Here's another one. Boat leaves Lighthouse A and sails 5.1 kilometers. At this time, it's sighted from Lighthouse B, 7.2 kilometers west of A. The bearing of the boat from B is north 65 degrees, 10 minutes east. How far is the boat from B? Oof. Because this right here, this is a real humdinger. So, you guys, when you get a humdinger like this, always remember what Rod Stewart said. So that tells me let's draw a picture, right? And the only way to draw the picture is to start. So let's see, a boat leaves Lighthouse A and sails 5.1 kilometers. So let's say Lighthouse A, let's say it's right here. Right? It's not telling us which direction it goes, right? Sails 5.1 kilometers, but at this time it's sighted from Lighthouse B, which is 7.2 kilometers west of A. So we do know this. If this is A, then B's over here. Right? B's over here, 7.2 kilometers to the west of A. So we do know that. Okay, so now the boat could have gone 5.1 kilometers this way, this way, this way. We don't know, but we do know where Lighthouse B is. Now, the bearing of the boat from B is north 65 degrees, 10 minutes east. So now we're on to something. Let's say here's a little compass on B. Okay, the boat is north 65 degrees, 10 minutes east. So that means instead of going due north, we swing to the east. The boat's over here somewhere. Right, the boat's over here, 65 degrees, 10 minutes to the east, right? Because to the left is east. I could write that 10 a little nicer in there, I think. 10 degrees. Okay, so that means this right here, the boat sailed 5.1 kilometers right there. Okay, so how far is the boat from B? So we want to find this distance right here. So maybe I'll go over, let's see, maybe I'll highlight it here. If I highlight it, this is what we're wanting to find right there. How far is the boat from Lighthouse B? So let's call this D. That would be our distance. That's what we want to find. All right, so what can we do here? Well, if this is 65 degrees, 10 minutes, right, then if I subtract that from 90, that would be this angle right here, because this is a right angle. So to avoid careless mistakes, I'm going to come in here, whoops, and I'm going to do 90, whoops, 90 minus 65 degrees. So I exited out just so I can remember again. To get the degrees, minutes, seconds, I go Option, scroll over, Angle, F4. 65 degrees, 10 minutes. And then if I hit F5, it puts it back in degrees and minutes. So 24 degrees, 50 minutes. So this right here is 24 degrees, 50 minutes. All right, you guys, look at this. They gave us an angle side pair. But here's a side, that's the angle opposite. Darn it. You guys, look at that. We don't know this angle, right? Opposite this D. So we got to find this angle. We got to find angle A. Well, let's see. We know side angle pair here. We know this side. We don't know this angle. So keeping the theme of A, B, C, let's call this C. We should be able to find angle C using the law of sines, right? If I put my angle side pair, 5.1 over the sine of 24 degrees, 50 minutes, that should equal 7.2 over the sine of angle C. So if I want to find angle C, I'm going to cross multiply and divide, and I want to find the angle. So I'm going to do 7.2 times the sine of 24 degrees, 50 minutes. And I'm going to divide it by 5.1. That's what the sine of angle C should be. So to find the angle, I do inverse sine of that answer. And let's see, keeping the theme of degrees, minutes, seconds, I'll convert it back. We'll go to the nearest minute, so that's what they did. So 38 degrees, 8 minutes. So angle C is 38 degrees, 8 minutes. I can hear you guys right now, or it could also be, you're right, we got to be careful, it could also be 180 minus that. Right? Whenever we use the law of sines, we do inverse sine, there's two possible answers in between 0 and 180 that give us a positive answer. So if I take 180 minus that angle, it could also be 141 degrees, 52 minutes. 141 degrees, 52 minutes. And that angle could be here. Guys, it could be that this boat went way out like this, right? Or could it be? Let's think about that for a minute. It traveled 5.1 kilometers, right? So if it went 5.1 kilometers this way, could this get to it? It'd be a weird looking triangle, but it's possible from what we've done. So we're going to have to check into that. Okay, we're going to have to check that as we work. Okay, so maybe trying to picture this other scenario. You guys, if we've got this triangle here, and we know for sure that this angle right here is 24 degrees, 50 minutes. And we know this is 7.2. And now we just discovered this angle C, and I was drawing this incorrectly here, but this angle C could be 141.52. So this angle C, let's see, 90 would be about like that. I don't know, I'm not real good at drawing. This angle C right here, this could be 141 degrees, 52 minutes. If I do that, this isn't going to be a triangle anymore. How would I draw it? See, guys, this is part of the problem of trying to draw this. I'm going to pause this video and think about this drawing. All right, I think I've got a little bit of a grasp on it, but it's drawing these things. It's nice when all the angles are nice acute here, and what's going on with this one here, when we go through and we find C is 38.08, then in this triangle right here, right, angle A is going to be 180 minus 24 degrees, 50 minutes, minus 38 degrees, 8 minutes. So see, it's going to be 117 degrees, 2 minutes. So this is going to be 117 degrees, 2 minutes. So my little generic drawing sort of threw me off. This one's when it comes out here. Okay, and the distance is going to be a lot bigger in this one than in this one. So now in this one right here, this angle right here is going to be 180 minus the 24 degrees, 50 minutes that we had. But then minus the other angle would be 141 degrees, 52 minutes. So in this other triangle, angle A is going to be 13.3 degrees. Well, let's see. Let's keep in the theme of degrees, minutes, seconds. 13 degrees, 18 minutes. So 13 degrees, 18 minutes. Okay, so there's two possible distances this boat could be from B. Okay, in this first triangle right here, if we stick with our angle side pair, right, 5.1 over sine of 24 degrees, 50 minutes. 5.1 over the sine of 24 degrees, 50 minutes. Okay, in this first triangle, that's going to equal D over the sine of 117 degrees, 2 minutes. D over the sine of, what did I say, 117 degrees, 2 minutes. Okay, in the other triangle, it's going to equal D over the sine of 13 degrees, 18 minutes. 13 degrees, 18 minutes. Okay, so to find the first one, if we cross multiply and divide, D is going to be 5.1 times the sine of 117 degrees, 2 minutes, divided by the sine of 24 degrees, 50 minutes. So it's going to be 10.81, 10.82 kilometers. All right, you guys, here's something. Here's a careless mistake I think I caught. So I was going through here. When I did this right here to find angle C, when I did 5.1 over the sine of 24 degrees, 50 minutes, it's going to equal 7.2 over the sine of C. I think I should have got 36 degrees, 22 minutes, not 38.08. Right, because I do sine, inverse sine of 7.2, sine of 24 degrees, 50 minutes divided by 5.1. I'm getting 36 degrees, if I round this up, 22 minutes. So this right here, I apologize for this, I need to correct this. This should have been 36 degrees, 22 minutes. Whoops. 22 minutes, which then would change this. This is going to have to be 180 minus that. So, because since I made a mistake, this might be a good time too to show you that I could do this without a calculator. If I was going to do 180 degrees and subtract 36 degrees, 22 minutes, what I would do is borrow from this and make this 179 degrees. And since 1 degree is 60 minutes, then I'd make it 60 minutes. Then 60 minus 22 would give me 38 minutes. Then 179 minus 36 would give me 143 degrees, 38 minutes. So that would be the other angle, 143 degrees, 38 minutes, which that's going to change these angles in here. right? It's going to change this. This angle here should have been 143 degrees, 38 minutes. And then up here, this angle should have been 36 degrees, 22 minutes. Which then, guys, when we came through and found these, right, we need to find this angle opposite. So this angle right here now should have been 180 minus 24 degrees, 50 minutes, minus 36 degrees, 22 minutes. Whoops. Whoops, I forgot. See, like, it's even telling me I forgot my minutes there. I forgot the same thing here, minutes. So that turns out to be, whoops. Come on. Change that to degrees, minutes, seconds. 118 degrees, 48 minutes. So 118 degrees, 48 minutes. So that means when I come down here, this right here should have been 118 degrees, 48 minutes. 118 degrees, 48 minutes. And this angle right here is going to change as well. And so is this answer. Okay, so in the other triangle, all right, if this is 143 degrees, 38 minutes, then I'm going to have to do the same thing here, except, did I come up here? When I subtract it out, this 36 degrees, 22 minutes becomes 143, 38. So 143, 38. So that angle turns out to be 11 degrees, 32 minutes. So 11 degrees, 32 minutes. So this is going to be 11 degrees, 32 minutes. Okay, so now let's try this again. Let's see if we can get the answer here. If I want to find the distance of the first scenario, I'm going to do 5.1 times the sine of 118 degrees, 48 minutes. And I'm going to divide that by the sine of 24 degrees, 50 minutes. And I'll get a distance of 10.641 kilometers. 10.641 kilometers. Okay, that's the distance in this first scenario. Okay, in the other scenario, the distance could have been the exact same thing, but when I cross multiply, instead of multiplying by the sine of 118.48, I'm going to do a 1132. So I can take this same thing, and this would be 11 degrees, 32 minutes. So 2.428 kilometers. So 2.428 kilometers. All right, so this was a good example of how you have to be diligent there. Watch for careless little mistakes. But this was a really cool problem, right? Now we know if these people are trying to get back, there's actually two different distances they could be. I know what you're thinking. Hey, what's their bearing? Right? Well, the bearing's different depending on which way they went. So maybe we'll do this in class. We'll find the bearing. Right? If somebody wanted to get to them from Lighthouse, or if they wanted to get back, go somewhere, what bearing would they have to take? Okay. All right. So guys, these problems, law of sines itself, pretty darn straightforward. Right? If you've got a triangle, the ratio of a side divided by the sine of the angle opposite, they should be equal for all three sides and all three angles. Okay, you can do them word problems, you can do a lot of different things. Okay, as you work these, make sure you do the homework, make sure you ask questions, make sure you check your answers, stay diligent, and always endeavor to persevere. Thanks for watching this video, and I hope it helps you.